హాయ్ ఫ్రెండ్స్, హాయ్ ఎవరీవన్, వెల్కమ్ టు అవర్ ఛానల్ బిఎస్సి ఇంజనీర్. సో ఈ రోజు వీడియోలో మనం మెయిన్గా ఫ్లెక్సిబుల్ పేమెంట్స్ వర్సెస్ రిజిడ్ పేమెంట్ గురించి తెలుసుకుందాం. సో వాట్ ఈస్ దిస్ ఫ్లెక్సిబుల్ పేమెంట్ అండ్ వాట్ ఈస్ దిస్ రిజిడ్ పేమెంట్? సో మనం జనరల్గా డే టు డే లైఫ్లో మనం చూసే పేమెంట్స్ చూసినట్లయితే కనుక మనకి ఫ్రీక్వెంట్గా కనిపించేవి ఏంటి అంటే మెయిన్గా బీటీ రోడ్స్ అలాగే సీసీ రోడ్స్. సో ఈ రెండింటి గురించి మనం బాగా వినుంటాం. సో అదేవిధంగా మనం చూసిన వాటిలో మనకు మెయిన్గా కనిపించేవి గ్రావెల్ రోడ్స్ అలాగే ఎన్హెచ్ రోడ్స్. సో ఇవి మనం మెయిన్గా చూస్తున్న రోడ్స్. అయితే వాట్ ఈస్ దిస్ ఫ్లెక్సిబుల్ పేమెంట్ అండ్ రిజిడ్ పేమెంట్? సో ఇఫ్ యూ సీ ఆల్ దీస్ టైప్స్ అండ్ ఇఫ్ యూ కేటగరైజ్ స్ట్రక్చరల్గా కనుక వీటిని డివైడ్ చేసినట్లయితే మనకి బేసిక్గా మనకి ఫండమెంటల్స్ ప్రకారం వీ హ్యావ్ ఓన్లీ టూ టైప్స్. ఇవన్నిటిని కూడా మనం టూ టైప్స్ కింద కేటగరైజ్ చేయొచ్చు. That is what flexible payments and rigid payments. So let us move into the video and see what is this flexible payment and what is this rigid payment and what are the differences between this flexible payment and rigid payment. So now coming to flexible payments. So if flexible payments, why it was named flexible payment means because they have negligible flexural strength. So flexible payment అన్న పేరే ఎందుకు వచ్చినాయి అంటే బికాస్ ఆఫ్ దేర్ వెరీ లెస్, దే ఆర్ హ్యావింగ్ వెరీ లెస్ ఆర్ నెగ్లిజిబుల్ flexural strength. So if the flexural strength is very less, what does it say? That itself it says that they can undergo deformation. They can undergo deformation very easily under deformation easily under loads over it. Okay, so when the loads are acting on it, when a load is acting on it, they will undergo deformation very easily because the reason is they are having very less flexural strength. So whenever this flexural strength is becoming lower and lower, the rigidity is going to get reduced. So it can easily deform. That is why deformation is it can undergo deformation and deformation is very easily seen under loads over it. So that is about flexible payment. That is the reason these payments are referred as flexible payments. And the best example for these flexible payments in day-to-day life is all kinds of BT roads. BT roads means bitumen roads, bitumen or tar roads, what you see nowadays, all these are coming under flexible payments only. So these flexible payments, when you are designing these flexible payments, they are designed in such a way that the load which is going to reach from this point means from the top surface to the bottom layer is subgrade. In between we are having a different number of layers with these flexible payments. Okay, so when it is reaching to the end, means when it is reaching the subgrade, they are designed in such a way that the load which is reaching the subgrade will not be more than the load reaching subgrade is less than the bearing capacity of subgrade. Bearing capacity of subgrade. The subgrade layer, the soil subgrade which was there below this. So based on that, the bearing capacity of the subgrade. So the pavement is designed in such a way that the load reaching the point, the time it is reaching, this load is reaching this end point in this way. So by here the intensity of the load should be such a way that it is less than the bearing capacity of the subgrade layer. Okay, so that is so now coming to the rigid payment, let us know about rigid payment. So why these payments are called rigid payments? So why it is called rigid payment? Name itself says. సో మనకి ఇక్కడ రిజిడ్ పేమెంట్ అని ఎందుకు అంటారు అంటే మెయిన్గా దీస్ పేమెంట్స్ ఆర్ హ్యావింగ్ హై ఫ్లెక్సురల్ రిజిడిటీ. or flexural stress, flexural strength. సో ఇందాక ముందుసారి చెప్పుకున్నాం కదా. సో ముందుసారి ఏంటంటే అంటే ఫ్లెక్సిబుల్ పేమెంట్లో వచ్చేసరికి flexural strength or flexural rigidity is very very less, but here it is having very high flexural rigidity or flexural strength. So because of this high flexural strength, what is going to happen? Deformation is also very very less. So when the deformation is very very less and the flexural rigidity or flexural strength of that CC concrete slab, here mainly it is laid in CC concrete slab. Okay, so the concrete slab is having high flexural rigidity as well as deformation is also very very less. Then that is the reason these pavements are called rigid pavements. So and mainly due to a high modulus of velocity, due to high modulus of elasticity. So that is another reason. Mainly because of all these three reasons, it is said to be a rigid pavement. So here mainly concrete roads or concrete slabs are laid as a pavement layer. So if you see the figure, here we can see there will be very very less number of layers. Only subgrade, over that subgrade we are laying base course, over that only we have CC pavement or cement slab as the pavement. So here when we are designing this rigid pavements, mainly we design in such a way that this pavement is capable of distributing load over a large area. So here if you see the distribution diagram, so if the load is acting here, so here it is completely a concrete slab, right? So the load, for example, up to here it is one panel of concrete slab. The load will be distributed accordingly from this panel. So this way it will be distributed. So the entire load will be distributed over a larger area. So here the area of distribution is very very large when compared to load acting area. So because of this, capable of distributing load over a large area, that in that way only we are going to design this pavement. These pavements are designed in such a way that they are capable of distributing the load over a large area with a small deformation, with a small amount of deformation. So deformation, what is going to take place here, and this delta value will be very very small value or very very less value will be there. So in that way only we are going to design, and also to minimize, and also we are going to design in such a way that to minimize the need of more layers. So here we will not have any more number of layers in order to reduce number of layers and to reduce stress also, and also reduce stress. More layers and to reduce stress also. Stress also will be reduced directly. So that is the basic thing about rigid pavements. When we are designing these rigid pavements, they should be designed in such a way that they are capable of distributing the load for a large area with small amount of deformation. Where we want in such a way that they minimize the need of more number of layers and also to reduce the stress. So this is also basic about rigid pavements. Now let us compare between the flexible pavements and rigid pavements. Comparison, coming to the comparison, first of all we'll see about flexible pavements. First one, the load transfer. So here with the flexible pavements, load transfer is going to take place from grain to grain distribution is going to take place. Grain to grain means if these are particles, so from one grain to another grain, that way from that grain to another grain. So this way from grain to grain load transfer is going to take place with the case of flexible payments. Grain to grain transfer is going to take place. So that is the reason the flexible rigidity or flexible strength is very less here. Why? Because the load is going to be transferred from grain to grain. So that is why rigidness is going to be offered. The rigidness offered here with this pavement is very less. Next, design. Design depends on, when we are designing these pavements, it depends mainly on the stability of subgrade. So the entire design of this flexible pavement is dependent on the subgrade. Whether the subgrade is good, the capability, load taking capability of the pavement is also very good with these flexible pavements mainly. So the soil stability, the soil which was available in that area, the stability of that subgrade or that soil should be very much high, so that the design is completely depending on the stability of that subgrade. So that is why it is also very important. Third one, as per IRC 37 2012 code, as per IRC 37 2012 code, we are going to design this flexible pavements. Okay, so that is very important. Next, stability is due to aggregate interlocking. How the strength is going to be developed here, or stability of this flexible pavement is existing mainly because of interlocking of aggregates. As we all know that in case of closely packed arrangement, density will be more. In case of closely packed arrangement, density will be more. That is why here, because of good interlocking between the aggregates as well as the particle friction between the particles, particle friction, and also mainly due to cohesion between the particles. So because of all these three reasons, bonding is there. Bonding, because of that only stability is going to be induced. More strength is going to be induced, or stability is going to be induced into the pavement because of this interlocking of aggregates as well as particle friction and cohesion between the particles. Next one, flexible pavement shows a deflection on the surface, deflection of the subgrade at the surface of the pavement, deflection of below layers on surface. So if it is there any deflection or any deterioration, or if any uneven settlement has taken place in between the layers, that will be reflected in the on the surface, on the top layer it is going to be reflected. That is the drawback with these flexible pavements. Whatever uneven settlements or whatever deformations is going to take place because of heavier loads in this flexible pavement, that will be reflected, or that will be shown on the, that will be exhibited on the surface itself, surface of the pavement. Okay, surface of pavement. So that is why it is little bit disadvantage with this flexible pavement. Next, design life. How much years we are going to design for serviceability of around 15 years we are going to take that design life or design period we are going to take for 15 years. Okay, this is with flexible pavements. Now move on to rigid pavement. So now coming to the rigid pavement, if you see rigid pavement points, so rigid pavement it is having good flexural strength. Good flexural strength. strength, and that is the base for the major factor of design, or entire design is depending on the flexural strength of that pavement. So it is the major factor for design. So design is completely dependent on the flexural strength of the pavement. So that is why it is the major factor for the design, that is with the rigid pavement. Next, concrete layer on the top, base course and soil subgrade are under it. It is having only 3 layers or 2 layers we can say. It is having only 2 layers, concrete pavement and subbase layer over subgrade, soil subgrade. Okay, so over the subgrade or over the existing soil subgrade, only subbase layer and concrete pavement is going to be laid in this rigid pavements. Okay, that is one point. And third one, it can distribute the load over a wide area because of its high flexural strength. Load can be distributed over a larger area due to its high flexural strength. Due to its high flexural strength. Next one, load transfer is done by slab action. Load transfer in this case with the flexible pavements, it is from grain to grain transfer. So here load transfer is by slab action. Just like a slab, and the load is going to be transferred to ends. Okay, so that is what we call slab action. To the supports it is going to be transferred. Load transfer is done by slab action. Next one, total thickness of pavement is less than total thickness is less than thickness of a flexible pavement. So layer thickness is going to be less, that is why total thickness of the pavement is also going to be less with this rigid pavements, whereas that is high for flexible pavements. Next, this design is done based on IRC 58. ఇక్కడ 37 కదా, సో ఇక్కడ వచ్చేసరికి IRC 58 2011. As per this we are going to design this flexible pavements. Next, design life వచ్చేసరికి around 30 years is the design life. So these are the main comparisons between the flexible pavement and the rigid pavement. Okay, so hope this video is useful for you everyone. Thank you.